A very warm pleasantries to the respected judges, benefactors, sponsoring companies, and faculty members. I would like to appreciate each and every one of you making time in this difficult situation to come and learn more about my research work. As part of my research experience for undergraduates, I was working with the civil engineering department on a study of gas migrations, primarily methane. I was lucky to be part of such a fantastic team, and being guided by them made me understand many aspects of the real civil engineering world. The goal of this research is to estimate the size of gas migration in soil from the leak source. We are able to find the migration pathway by finding the location of each inserted bar hole with respect to the leak. This gives us an idea of how far the methane has traveled when an underground pipe leakage occurs. Using the data provided by our four partner companies, we were able to study the gas leakage scenario of about 80 different field sites and estimate the area of methane migration in each of them. By studying this information, we can help the surrounding community by allowing us to determine what areas would be directly contaminated with methane, and we can take measures to limit its consequences. The approach of this research is simple. We first analyze the collected data of the field sites provided by the companies. It is important to understand that most of the provided data is separated into three different sections: the initial detection, the additional detection, and the final repair. These data consist of tables with appropriate values, sketches, photographs, and handwritten notes. Our objective is to organize and analyze all this information to create a single outline of the field sites, illustrating all the given materials and details. As you can see, I have two example layouts that were created using PowerPoint. The layout consists of the location of the inserted bar holes, the gas pipelines, the leak source, the soil profile, and other relevant details. The soil profile was created by performing parameter testing on the samples to determine the classification of each provided soil sample. After we were able to visualize the given data and produce a digitized layout of the field site, we can measure the distance of the bar holes from the leak source. We take the horizontal distance in the east-west direction and the vertical distance in the north-south direction of each bar hole with respect to the source of leak. We input these measurements into an Excel spreadsheet to find the total bar hole distance. To validate our layouts created, we plotted the horizontal and vertical distances to give us the exact location of the bar holes with respect to its distance from the leak. The x-axis gives us the east-west direction in feet, and the y-axis gives us the north-south direction in feet. The trend line you observe in the plots can be used as a reference point to highlight how far each bar hole is inserted from the leak source. This information then can help us calculate how far methane has traveled from the location, because we are provided with each bar hole reading and its distances. In conclusion, we are able to estimate the methane migration pathway by determining the distance of each inserted bar hole with respect to the leak source. This information can be used as a safety hazard tool and can open doors to wider range of research work involving the study of gas pipe leakage and methane migrations. Finally, I'd like to acknowledge the U.S. Department of Transportation, Pipeline and Hazardous Materials Safety Administration for funding this highly applicable research. And lastly, I'd like to thank my mentors, Dr. Kathleen Smith and Yunki Cho, for helping me in every step of this research journey. Without them, this would be unachievable. Everyone, thank you so much.